Hello everyone and welcome to the Robot Party. The Robot Party is a hangout where a bunch of robot builders can get together and show off their robots, discuss what their robots do and sometimes what they don't do or when it breaks, and also help other robot builders. And so luckily we have a lot of people from around the world this time, which is pretty cool. So we'll start out with Roger. Roger, can you tell us all about your robots and show them to us?
Sure. Hello, everybody. We're the two guys from Switzerland. Michael. Three guys. That's Kitty, our little robot. We go later a little bit around. You can see our big robot. But we will keep it short because a lot of people want to show it. We have a smartphone-based system. We take the smartphone as controller, and it talks all the time like you hear. And that's the base of our system. And we're printing out our robots, so we hope that makes it cheap. So that's the first thing about what we do.
So Kitty uses like a microphone to sense its environment. Is that what you're getting to? Oh no. No. Frozen in time. Alright, well, hopefully Roger will come back online. In the meantime, let's see what... Oh, no, okay. Let's see what Louie's robots are like. Or just one robot. Louie, can you show us Hello Spoon?
Oh, okay. Hello, guys. My name is...
Hello?
Roger is back.
Oh, Rod. Yay!
Oh, sorry, we fall out. Okay, go ahead, Louis. Sorry.
Are you sure?
Yeah, sure. We coming back later.
Okay. As I was saying, my name is Luis Garcia. I'm from Mexico, and I'm working in a little robot named Hello Spoon. I have like 1 year and a half working, and I want to show you the first version. This is part of the first version. It's like only a wood box. And here's the second version, which is really, really big. And here's the actual version. Here's Hello Spoon Robot. It's intended to help children with upper limb difficulties and special needs to have a fun and happy mealtime. As you can see, it's the wood body, robotic arm of 5DOF. It's an OpenCM 9.04 right here, and some batteries inside here. And the main core is a mobile application. So the main idea is make Hello Spoon as a really affordable solution and something completely different. There are other solutions that are only robots. They are so old, they are not cute, they are not offering the communication with the user. But Hello Spoon talks to you, Hello Spoon cheer you up, dances, and all that stuff. Here's the main app. You only have two options. The option to put some settings. As I told you, you can Hello Spoon cheers you up. Hello Spoon play songs and that, and you can turn it off or you can turn it on. It's according to the user, and it's communicating with Bluetooth. So let me see if I can show you a little bit of Hellspoon.
Yes, we get to see it in action.
Yeah. So okay. So as I told you, here's the app. Now it's going to connect with Hellspoon. It takes a little bit because Bluetooth is like a little laggy.
Okay. Oh, there it is.
Food. Also, it works with pocket spins. Yes. So you can see in the back that it's moving. I don't have actual food there, but that this is the main, and he can chew you up, and he's sensing when you put your mouth here.
Wow. How does it sense when you put your mouth there? Is it a button?
Well, I'm using Dynamixel XL320, and they are really smart. Ooh. Sometimes it tends to fail.
The music really adds a nice touch to it.
Oh yes, it was made by a friend named Genux. He's he's a supporter from Hellspoon.
So how does the spoon know where the human's mouth is? Like, how does it adjust for that height?
Well, right now it's in a fixed position. Um, so right now the ball is all the time in the same place, and it's going to the mouth to the same place. But the idea is that you can set that. I mean, the nurse or the parent can set that, can teach Hello Spoon where is the ball and where is going to be the mouth. That is already implemented, but I can show you right now because it's not on the main app. So you can watch videos about Hello Spoon, and you will see that.
Cool.
Yeah.
So it definitely seems like you mentioned this even before that the communication with the user is super important because if it doesn't look cute, or maybe cute
Yes.
isn't the best word, then they won't really be interested in using it.
Uh huh.
So how did you experiment to get this design and approach down, right, so that they aren't scared of a robot arm coming towards them?
Well, I'm not really sure if the children are going to be scared. Actually, the next week I'm going to do my first children test after
Okay.
1 year.
Oh, yeah. Wow. Okay.
So yeah, so it's
Cool.
going to be really fun, I guess. So I'm expecting that they are going to react okay, or at least they are going to be happy. I hope so.
Very cool. It will be interesting to see how much of a difference it will make in
Yes,
lives, hopefully.
yes, yes. It will be really, really cool.
So, how long have you been working on Hello Spoon?
I just started like 1 year and a half. Right now, I have more than 1 year working. Uh, the first version was actually this one, and the application was only a spoon friend that was talking to the user. So actually, the main core is the same, but right now it's an elephant. It's a blue elephant.
Sorry about that.
Yeah, don't worry.
Very cool. Um, This is just such a cool robot. I like how you intertwine the software and the hardware together.
Uh-huh. No, thank you. I have a lot of time working on this, and I'm expecting to have a good result with the final user. So let's see what's going on then.
Just another quick question. How did you get the arm to move to certain positions in space? Did you have to do any special calculations for that?
Uh, I created one app also named Hello Spoon Animator. So I'm using one of the good features from Dynamixel XL320, that is that it's always sensing where the actuator is. So I'm kind of teaching Hello Spoon where is going to be the mouth, where is going to be the ball, and which ones are the motions that Hello Spoon has to do to look natural, to look good and smooth.
Wow, fantastic.
Yeah, so I'm not doing the mathematics, the raw mathematics, but it's all like computer science stuff.
All right, and where can people learn more about your robot?
They can subscribe to the YouTube channel Hello Spoon Robot, or they can go to the Twitter feed Hello Spoon, or they can visit the web page, which is really basic. Actually, it's only one video, but it's hellospoonrobot.com, or they can only follow me through Google Plus, and I'm updating stuff all the time.
All right, Hello Spoon is all over the internet.
Yeah, all over the internet.
All right, great. Thanks for showing off your robot.
You're welcome.
Really
Thank
cool.
you for inviting me here. You know, it's really cool.
Yeah, first robot party, woohoo!
Yeah.
All right, let's go back to Roger. And
Okay, awesome.
yeah, thank you, Luis.
Thank you.
All right, hopefully you won't get disconnected this time.
Okay.
Hello, everybody. You have a look at Europe.
Whoa! What is going on here?
Thanks to Luis for presentation your robot, and thanks to you, Erin. We tried to make it quick because we don't know how good to connect, because first time it's not out. So Michael goes around with the cam. I tell you something about our robot. I'm sorry, we're talking sometimes this German because Michael is not really talking. I'm sorry. That's our systems, our parts. They're printed out of 3D printer system, Ultimaker we were working with. And that's our first prototype, a humanoid robot controlled by a smartphone. It's not in it, I don't know, and has 24 stuffs. How do you call that? Servos, control robot, 24 sensors. That's our high-end product. And you see here part of Kitty, our small one. Kitty is not just a robot, it's a concept, because we are selling the part. And just with stick turbo. But it makes a nice walk. If you have fun, you can see Kitty walking. Michael, we get a message. Do you see anything? Please.
Oh yeah, we can see Kitty right now. Yeah.
Okay. Yeah, it looks like. That's Kitty.
Leave me alone. There's something in my way. I turn around.
Wow, robot with attitude.
Now we make okay.
Kitty, sorry. Kitty does not know how to react to this command.
Kitty is sometimes a little bastard, sorry, but not always listening.
This is so cool.
Okay, we tell you just a little bit about it. It's on Pololu servo card. We did write an unknown plugin to. Okay, ist wieder cool. Sorry. A known plugin, and we will sell this system soon at the web. So if you're interested, have a look. Thanks a lot, Ed, so far. Oh, before I quit, I want to show you our big robot in just a quick look. That's the first one you might saw before on the web.
Oh no, the phone has disconnected its video.
Okay. Do you see anything, please?
No, not on the phone anymore.
Oh. Sorry, we have some cameras more. Michael shows you. That's the lag system printed out.
Wow.
And we work with standard servos, so you know what we're doing. Probably one of the guys don't work at the moment, let's say for the moment, with robot is dynamic serve. We have standard serve, but we think at the moment it doesn't matter at that. And we show you the over body.
Wow.
Printed out with 3D printing. Okay, guys. For the moment, that's from Switzerland, and soon we're coming out with our product. And thanks for interesting.
Well, thanks for showing us your robots. I think we got a bit of the explanations there. So, can you hear us fine?
Yeah, sure.
Okay.
My English is not the best, but okay, Erin, don't talk too fast. Maybe you understand something.
Alright, so for Kitty, it uses a smartphone to control the robot?
Absolute, that's correct. We don't need an extra controller like Arduino or a Raspberry Pi. That was the idea, because, sorry guys, it makes no sense to control, or to have controllers in stereo. That was the idea about. And that's what we're making. We have a quick bus, we're working with USB. We have a controller of Pololu, American servo controller producer. We're really proud to work with this product because it gives a lot of opportunities. And if you have interest on our product, you don't worry, you don't have to buy it, because we'll bring out plugin open source. That means you don't can code the USB controller, but you can work and combine it with your applications. Because the idea of it was big companies, they could get away, sorry, simple English, could get away our resources like nothing, and private developer, they don't, they will be happy. They don't have to start with controller device stuff like we did now. So that was the idea, and people should get that stuff really cheap. So yeah, well, that's the idea of it. Thanks a lot.
So how much more reliable is USB compared to, I guess, serial? And, well, yeah, I'm just not understanding, like, so you use USB host from the phone to
Yep.
communicate to a controller board, the Pololu one?
Absolute, and maybe the difference is the most of the other controller boards are programs on robots. They're working a lot on the controller. We took the main controlling system on the smartphone because the smartphone brings a lot of APIs, makes it to integrate, and at least we have the controlling system on one point on the smartphone. That was the idea for it.
So basically,
correct?
so basically, Kitty can run off of the same brain as Jin. It's just different software on both of them.
You're right. It's pretty close, and that's the idea of it. Kitty is just with 6 servers. We want to bring out something like a starting model, but developer don't have to buy Kitty to start with our software. We will bring out.
Oh no! What are they gonna bring out? We're left in suspense. Well, anyway, they said.
Where?
Oh, they're back. Oh,
okay. Sorry.
Bringing.
Okay, before we go and curve again, another question.
Well, thanks for showing us your robots. Maybe next time you could show Jin moving. That would be super cool.
We will do that. No, don't worry. We will do that because it's also available about September. That's our destination, and yeah, we will do that for sure. Thanks a lot.
Thanks for coming to the robot party. This is very cool. All the way from Switzerland. Thank you so much. All right, let's see. Who is next? Ashim, are you there? And can you show us your robots?
Yes, I am here. First of all, I would like to thank Erin and for inviting me to this robot party.
Well, thanks for coming. So, where are you in the world right now?
I'm from Nepal. It's in South Asia, near China.
So cool.
Thank you very much.
Yeah, so let's see what robot you're working on.
So right now I'm working on a Python app controlled robot, and what it does is I can control it via a graphical user interface, and I can control it through a keyboard as well.
Super. So, can you show us the robot in action?
I'll try. I'll give it a go.
Okay.
Yep.
Infra, there's something in my way. Leave me alone. There's something in my
That was Roger's room speaking. Okay.
So actually, it's a tiny little robot. Yeah, it's on top of an acrylic chassis from Pololu.
Cool.
And it uses micro metal gear motors, so it can go pretty fast at times.
And what are you using to control the motors?
Right now, I'm using an L29 3D motor driver and Arduino.
Cool. Are you using any special timers
So
for? Oh, go ahead, keep going.
I'll try to control it once, and
Woo, moved. Yes.
it's nothing much. I'm just sending characters from my computer wirelessly, and it receives certain characters, and it just executes the task which is written on the Arduino.
All right, cool. So you
So
have routines programmed on the Arduino, and then whenever it receives a character, then it will
ex
trigger that
exact
routine.
exactly, and there is a wireless communication going on. So I've used a pair of RF modules. So they are of 433 megahertz, the frequency.
Cool. Does that
Uh,
mean that, so how far can the wireless communication go before it cuts off?
yes, I was really interested on this question, so I gave it a go, and I succeeded in reaching distances of around 25 meters. So I think I need a larger
Wow.
antenna to increase the range.
And if there's a wall between the emitter and the robot, does it still receive the communication?
Uh, yes, it does, but the range is definitely reduced
Yeah.
a lot.
So you mentioned that the idea behind this was to create a medical robot. Can you tell us more about your idea?
Yes, actually, uh, first of all, I started playing around with Python, and I thought about sending characters wirelessly to a robot through a computer, and it's just a random idea actually, but what Medical Rover is trying to do is that it will be helping patients in hospitals through line following. For example, it will receive characters, commands to go to specific rooms via line following.
Cool. So,
And yes,
so in the hospitals or the clinics, there would be lines on the floor, and then the robots would be following the lines around.
exactly. And another interesting idea I was suggested on letsmakerobots.com was not to spread the track on the floor itself because it might be crowded at times. So a better idea might be to build a track maybe attached to the wall.
Yeah, that's a
So
different idea.
like a separate path for it.
They could almost be like model trains whizzing around,
Uh, I think so, something like that.
except a lot more intelligent, of course. So, what would the robot be transporting from room to room?
Right now, it's really small. So in the prototype stage, I think it's limited to transporting medicines and uh, and important information. Right now, I've taken out the LCD on the robot from the robot, so maybe it can transport important data too, but that would be faster through direct communication. But right now, I think it's limited to medicines and small packages, I think.
It's such a cool and futuristic idea.
Thank you very much, but it's still kind of a random idea, and it's a bit difficult to implement. But I'll give it a go.
Well, of course, it's worth trying. How would you achieve anything if you didn't try? And you're off to a really great start, too.
Thank you very much. I'm just actually Python made it really easy for me because uh, previously I thought the only way was sending data through the serial monitor from the Arduino, and that does not allow real-time exchange of data. So using Python, I can press a certain character on the keyboard and it's instantly sent over through the RF modules to the robot.
Very
So
cool.
it's there's a little bit of development going on, and I'll continue on this, and let's see what happens.
So what's the next thing you're going to add to it?
Right now, I think I'll be focusing more on the line following part. It follows lines really nicely, but I haven't been able to integrate the line following with receiving commands through the Python app. So it can move forward, backward through the Python GUI, but it cannot start following the line to the command. So I need to work on that part right now.
All right. Well, I'm looking forward to seeing it when it can follow lines and receive data.
Thank you very much. I'll be really happy to show it on letsmakerobots.com and on Robot Party as well,
Cool.
if it works.
Perfect. If it works. Perfect. Well, good luck with this robot, Ashim. Very cool.
Thank you very much. Thank you very much.
You should show it even if it doesn't work.
Yes.
Of course, I will keep on updating you on how it goes, and the GUI is also pretty simple right now, so I think I'll be adding a couple more buttons and more functions in the GUI, in the Python GUI. So they're just plans at the moment, and but letsmakerobots.com, it's such an awesome community, and I think I'll be getting a lot of help there to complete this project.
Yeah, for sure. LMR, all our bots belong to us. I think that's the phrase. Yeah.
Exactly.
All right, cool. Thanks for showing your robot, Ashim.
Thank you very much. And so this is the first time on Robot Party, actually.
Oh, yay! First robot party.
So yeah, it was pretty cool, and thank you for inviting me, and thank you everyone for sharing your cool ideas, your robots, and I hope to come soon again in the future.
Great. We look forward to it. All right. Thanks, Ashim. Let's see Andrey's robot. Andrey, can you show us and tell us about your robot?
Sure. So hello everybody once again. Thank you, Erin, very much for organizing it. It's really cool. I'm first time participating in the robot party. And
yay! First robot party.
I really like the idea. And what I'm going to show is our robotics vehicle. It looks like this.
Wow. Wow.
It's mainly a 3D printed robot. So all the body of the robot, the upper part, is actually 3D printed, and we are using available out-of-the-box chassis from Pololu. And the main motivation why we made this robot was because I'm kind of interested in autonomous navigation algorithms. And so I was looking for affordable and preferably open platform to experiment with. And to implement really autonomous behavior, there are quite a lot of requirements, mainly on the sensor amount of sensors available on the vehicle. There should be enough, and on the calculation power for the onboard computer, because some of the algorithms are pretty calculation intensive, and that's why it was important to have more or less powerful computer on board. And after looking for quite some time, I did not find anything which fits exactly these needs, and that's why I decided to build my own. So to address these requirements for autonomous navigation, what we have here is two cameras. So maybe you can see we're in the
Yeah.
heat here.
We can see the cameras. Yeah.
There are two cameras, and actually this heat could be rotated.
Ooh.
Currently, I'm controlling it over the Wi-Fi, so it can be rotated, and you can also see the ultrasound rangefinder here in front between two cameras.
Yeah.
In fact, there are actually three others ultrasound rangefinders, one on each side. It's
Yeah.
here, this black dot here, and the same as on the opposite side. Also, here is the one, and we also have the one on the back. So actually, so here's there. This is also the ultrasound rangefinder. So we have 4 ultrasound rangefinders looking in the 4 direction. We have 2 cameras, but also in addition, there is a mast. I don't know if you can see it good. So
Yep, we can see the mast. Yeah.
the mast, and inside this mast, we embed the GPS receiver and compass, an electronic compass. So this is a set of sensors which we have, and also, as you can see here, the antenna. So by default, we're just using the standard wireless connectivity, but this is actually the UMTS antenna. So we're currently experimenting with UMTS or 4G connectivity, and going to switch to LTE actually to control this this vehicle really from the from far distance.
From the world. Wow.
And from as an onboard computer, we are actually using the Beagle board, which is pretty famous open source open hardware platform. And Beagle board has this nice nice feature that the XM version of the Beagle board has a built-in DSP, the signal processor. And this signal processor makes it possible to stream the video in the real time. So we are compressing the video with H265 with a video codec in the real time and streaming the video over the network. So it's possible not only to drive this robot in an autonomous mode, but also we can do kind of teleoperation scenario where the driver can control it and remotely and see what the robot can see. So this is the from the hardware part, more or less, and from the software point of view, we implement, so this onboard computer is running just a normal Linux, and we implement the functionality which makes it possible to access all the sensor data as well as the motors and all the actuators remotely. So we can stream the sensor data in real time, process it on board or outside on some much more powerful computer, and send back the control signals. And by doing this way, we can say that it's a kind of hype currently in the robotics world, what is called the cloud robotics, where the actual processing happens not on board but on much more powerful computer. And we also have, so we provide a set of software which operates under real life conditions, like, for example, we implement firewall, traversal, and some security measures, so just to make it usable in the real life conditions. And we also implement as a demonstration what we call the driver console. The application, and I'll try to show it on my computer screen in a second. So here,
Yep, we can see the app.
So this is the application where you can see the live video stream from onboard cameras, and also some visualization for the sensor data, like a motor rotation speed, like a distance measured by ultrasound rangefinders. And right now I don't have the GPS signal here, but we are also loading the map data from the OpenStreetMap website and can visualize it here to illustrate the location of the vehicle. So, and we think that this platform is actually a very nice platform for those who are doing research in the autonomous navigation, autonomous localization. So for the robotics enthusiasts or maybe the PhD student, and it's also very well suited for just for educational purposes, because as a programming environment we are using Linux, and everything, software as well as all the CAD materials to print the robot, everything is completely open source. And here's I just post in chat the website. So here's our website where you can find all the details, all the link to software, to the hardware parts, to build it on yourself. Well, that's basically it from my side.
Wow, what a robot.
Thank you.
All right, so the people viewing can't see the chat, but I'll just spell out the name of the robot. So it's called Veter Robot, so VETEROBOT. So just Google that and you can find more about it. So, wow. So first of all, the 3D printed accessories are really nicely done. I mean, it looks like it's part of the robot chassis itself, so well done on that.
Thank you very much.
You have so many features on this robot. How long did it take you to develop all of this?
Well, in fact, it's hard to say because it's a kind of hobby project. So we only spend like evenings and weekends. So it's hard to say how exactly. But we're doing it since at least 5 years, starting from placing our electronic on just a standard RC car. But at some point of time, we decide to build our own chassis and our own body. So overall, it's like 5 years or something from the moment where we start building it and until now. But as I said, it's just evenings and weekends which we are using for it.
Wow, you must have learned so much things over that time. That's very cool. I really like how you're going to be using 4G to control the robot and send the video. That's very cool. So eventually, do you imagine being able to deploy that robot in generally inaccessible areas, and then you can drive it around teleoperated mode and do some exploration?
Yes, definitely. This is the scenario which is very typical for this kind of teleoperated robots. The point is, right now to control it, we need some kind of infrastructure like a Wi-Fi access point on connectivity, or as already mentioned, we are currently experimenting with 3G or UMTS connection. So it would be definitely possible if there is a way to stream the video from onboard cameras.
Wow. I bet everyone in here is just like imagining all the things they could do with this robot. Eventually, are you going to add on a 3D sensor so you can get point cloud info from its environment?
Oh, definitely. This is a very good idea. And in fact, we're already working on the way to mount the kind of 3D sensors. In particular, we're using the Asus camera, which is similar to Microsoft Kinect, but a little bit smaller. And yes, definitely, this would be probably the next step to improve the quality of the perception of the whole world and improve the quality of the autonomous navigation algorithms.
Wow. So what autonomous navigation algorithm would you recommend for beginners to get started with, say if they just have a robot with an ultrasonic sensor on it?
In fact, on our website, we actually have a demo page. And this demo page is a kind of special because all the demos you can see there are inspired by the very, very well online course taught by Professor Sebastian Thrun from Udacity. Udacity is an online platform. And I was taking this course and decided at some point of time to implement the exercises touted by this course, but using not a kind of simulated environment, but adapting these examples in such a way that they will really control our real vehicle. So,
so you did your homework in real life.
Something like this. And the nice part about it is that all these examples was written using Python, so it's pretty easy to start with. And to answer your question about the navigation algorithm, what was really fun to implement and easy to understand and actually works pretty well is a so-called particle filter. And
particle filter.
And on this demo page, I would there is also an example how it works, and there is also a source code available for this example. I will post the exact link to this page in a moment.
Very cool. Thank you so much for telling us all about your robot. Wow, it's just so much work on it and effort. It's just so cool to see it.
Thank you very much. I'm really glad that you like it. And once again, thank you for organizing this robot party. It's really something which I've never seen before. Really cool. And thank you to everybody else showing the project. It's really fun to look what the other people are doing live, and really appreciate it.
Oh, this is fantastic. I'll definitely post the URL to Vita Robot later on, so everyone can read and do their homework in real life too.
In fact, I already posted in chat the link to our main homepage, which is just vitarobot.org, and I will post in a moment a link to the demo page.
Cool. Thank you so much, Andrey, for showing your robot. Super work. Good luck with the future of it, for sure.
Thanks.
All right, next up, Stephen. Can you show us your robots?
Hi, yes. Can you hear me?
Yes, we can hear you.
So I'm a little disorganized here. I was out running, which is why I was slightly late to the party. But so I'm working on a multi-agent. Like the goal of the project basically is a multi-agent like tele-robotics system, and I built a quadruped. It's not walking yet because I'm still working on the inverse kinematics like algorithm for it. But this is basically the build. It's 4 degrees of freedom per leg. So it makes for something that's fairly flexible. I have the algorithm. I have an algorithm that will run one leg that works in multi-degrees of freedom. Basically, the algorithm itself is fairly computationally inexpensive. So I wrote some software in Python to build and test my inverse kinematics algorithms. So at the moment I'm working on the body IK. So I'm hoping to have the main build itself up and walking around hopefully by the next time we meet. So hopefully I'll have something that I can show with the actual robot itself walking around. Now, part of the project too is that I'm also really interested in sort of autonomy. I'm also interested in mobile robotics and also easy like user interfaces to robotics too. So with that being said, I'm also using I've got a wireless IP camera that I don't have it hooked up to my local network yet. I just moved into a new apartment, so I'm not fully set up. But so I have this wireless IP camera, which I'm mounting on and actually I have this hooked up, but
Okay.
I have a 2 degree of freedom camera mount. So basically, the wireless IP camera will sit on top of this mount, which provides pan and tilt.
So the camera can move around.
Yeah.
And what is it going to be looking for?
So the camera itself is actually, I've written an Android app, and I'll hook this up in a second just to show you. I'm doing wireless motion tracking with my phone. So I've written an Android app on my phone that takes the sensor information, the orientation data, and I smooth out that data. And I apologize, I have a cat here who's trying to eat at my wires. So I smooth the data, the raw orientation data, and I put it into like a 360 degree like rotational format, and then I wirelessly send that out of the USB port using this USB to go cable.
Okay.
So I plug this in, and I'll sort of demonstrate this working too. So this plugs into the bottom of my phone, which fires up the Android app. So the Android app itself will display the video from my wireless IP camera across like a Wi-Fi network.
Right.
And then the orientation data is sent out of the serial port to Arduino board that I have with a wireless XB module on there.
Okay.
And I've also got you can see that dangling there, a thumbstick. So the thumbstick itself will be used to drive the robot platform itself, and also the GUI on the Android phone. So you can basically switch between two modes. You've got robot control mode and UI mode. So the idea actually is that the phone itself. The idea is that it's not just that it's the phone. The phone itself is really just an Android wearable display. So this would be mounted in some way in the user's view, and it could be that one could use like Google Glass. So the idea then is that you create a really simple user interface into your robot platform. So you have the thumbstick for simply driving the robot, and then for motion, you're basically doing head tracking then with the phone. So wherever you look with the phone, with the video feed that's coming back to the Android app, that's basically where the robot will be looking as well, with the wireless mount.
Oh, cool.
Yeah, so I'll hook this up and I'll just show this working.
So, do you ever find there would be a latency issue with going from the phone to the Arduino via an XB connection?
Yeah, you know, one of the biggest problems with, especially like with what was I going to say, with like augmented reality, that sort of thing,
right.
is a latency issue.
Right.
So this wouldn't work in a fully immersive environment. This would be more like Google Glass. It would be something that would be in one's periphery. I did actually just order, to be able to mount this, I was originally going to just duct tape it to the front of like a baseball cap or something. But I actually just ordered Google Cardboard. I'm guessing some people here would be familiar with Google's Cardboard project, which is basically this cardboard setup that you fold up into, and that you can slot your phone into and wear it in front of your face. So at the next hangout, I will hopefully have this cardboard that I can put the phone into, so that it will actually be mounted to my head, and I can give you a better demonstration. But so the nice thing with the phone too is that the battery also powers the Arduino.
Okay.
So I don't need any additional
power. Cool.
So if I switch this on,
Let's see it in action. Woot, woot.
And I apologize, I don't have the best setup right now. Like I said, I just moved and I only have a camera on my
Alright.
so let's see if I can get something that you guys can see.
Yes. Let us see it.
So this might be kind of awkward, but
It beeped.
my phone is locked. So now I've got my phone and I've got my, it might be hard to see, but I'm basically wirelessly tracking the position of my phone.
Right. Oh, very cool. So the robot is mirroring the phone's movements.
Yeah, so if you imagine the camera would be mounted on top of here,
Yeah.
so wherever the camera would point, you would then see the video image on the phone's UI itself
Yeah.
as well.
Oh, this will be a super cool augmented reality app.
Yeah, and so it'll be cool once I get this up and running with the phone itself mounted to like my face, to my head, to be able to actually sort of strap it on and then just use my head itself. That'd be kind of cool to see too. I also have some rudimentary constraints on the two servos here because it won't run 360 degrees, so I have to constrain that. So what I basically do is that I find my constraint point. I don't recall what I have it set up at right now, but when I go beyond that constraint, it will stop, and then I get about halfway through.
Oh no.
The phone, and then it switches to the other side.
Yeah, so it has a dead zone.
Yeah, and then that will also help avoid getting my wires all chewed up and stressing my servos too.
What servos are you using?
So the servos, it's a little sort of jerky because the servos I have are a couple of years old. They're Dynamics or AX12s. So they're not super high end. They run about $40 each, I think, something like that, US dollars. At the moment, they were about 50 when I bought them.
All right.
And so as I progress with my project, the ultimate plan actually is to, once I get this one robot up and running, I plan on building like 2 or 3 of them, because I'm building a multi-agent system using quadrupeds. The reason I'm using quadrupeds is because I'm interested in sort of navigation of the natural sort of terrain and that sort of thing to allow for more flexibility with navigating stairs and things like that. So I plan on building another version with better flex servos and equipment, and then building maybe 2 or 3 of those because I then want to start adding in some multi-agent communication. So the idea is that you have like a leader-follower setup. So you would have one person controlling the leader, and then you would have semi-autonomous followers that will be also accessible by other people. If other people have like a phone, for instance, or some way of hooking into the video, then other people can sort of participate in sort of a group type setting. So that's sort of the plan.
Very cool. I think we're all looking forward to seeing how the AR app will turn out and how it will evolve in the future.
Yeah, I'm kind of excited, and like I said, hopefully I'll have I'm working on my inverse kinematics for the rest of the body right now, so I'm hoping that soon I'll have something where the robot itself will actually be moving around, be walking around. And at that point, I want to start sort of linking like videos to my website or something. So hopefully I'll have something I can post to like the robot party somewhere.
Yes.
Soon. And I'll also show, I won't show it today, just in terms of time. I'll let other people jump in, but next time maybe, or maybe I'll get some video, I'll show you my my Python app as well. I'd have to switch over to my phone for the video, and I can show you my inverse kinematics that I have running in simulation at the moment in the Python app.
Cool. Everyone has Python apps. Woohoo!
I've got a bit of Python, Java on the phone, and of course all of the Arduino stuff.
Right.
Yeah. I'll put a link to my website if anyone is interested in chat here as well.
Fantastic. All right. Thank you, Stephen, for showing off your robot. And
Thank you so much.
Where in the world are you joining us from, by the way?
Oh, so I'm from England originally, but
Wow.
I was living in Madison, Wisconsin for a while, and I just moved to Minneapolis.
Oh, okay.
So the Twin Cities. I just moved here like 2 weeks ago, and so
Oh, okay.
with a
You're
move.
just for USA. That's
Yeah.
just kidding.
I haven't been able to work on my project much the last like 2 months, but I'm just kind of getting back into it. So this party hangout is actually great timing.
Oh, fantastic. We all look forward to seeing how the project will progress from here.
Yeah, thanks so much. Thanks for setting this up. This is really great. It's great to get back to this with you guys.
Super. All right, let's see. Who next? Which lucky robot will be next? All right, Atom, let's see. Oh, let's see what your robot is looking at. It's looking at the outdoors. Cool. Atom, can you show us?
I'm here. Yeah, I feel kind of embarrassed because I actually didn't create this robot. I'm just building apps for it. And I might try a different robot. What I've got right now is a DJI Phantom hooked up. Let's see if I can. I'm going to launch it and then let's see what happens. I'm going to have to I have to screen share the image with Google Hangout, so give me a second and I'll get it up in the air.
All right. So DJI Phantom. Interesting name.
All right. Might be a little.
This is so cool. We're hanging out on a flying robot. How cool is this?
I'm going to change the view real quick.
Whoa. I think this is the very first hangout with a flying robot live. This is so cool. Oh my gosh.
So I guess a couple of things. The reason I wanted the DJI is because it's really a stable platform. Definitely a very closed source. So implementing like APIs to it is going to be difficult without re-engineering the firmware on the nozzle board, which controller. I've just recently acquired this, probably like 6 months, so I haven't really messed with the firmware on the board itself. But I guess my plan is like he was speaking before, I got Google Glass, and I'm going to actually transport the image coming from the drone into my glass. And then I want to use the lead motion sensor to pilot it. And what I'm thinking about doing is putting like a router in a backpack along with the laptop that's going to do the processing from the lead sensor and also grab the image from the drone. So it'd probably be like a decently high gain antenna. And then I'd pilot it that way. And then also might integrate some GPS. Like I said, with this one, it's going to be hard to get the GPS data from the drone itself. So I might approach it with a different drone. It's more open source. But I guess the idea would be getting the GPS coordinates from the drone, and then also getting GPS data from where I'm at, so from my phone. And that way I could have the drone follow me around. And then I could use Google Glass to contact the robot, telling it where to go, like what coordinate position, or maybe hide, go higher, forward 10 feet, things like that. So that's kind of where I was going with it.
Wow.
I'm gonna try to drive it and see, because I'm not sure where it is. I know it's like above my house here, but let's see how high we can go before we lose it.
Oh man.
What's cool about this one is if it goes too high and goes out of range, it will just land back where it took off.
That's pretty intelligent. Oh,
Oh, I just lost it.
there it is.
It'll come back. Yeah, that's probably like the maximum height. Probably go.
Wow.
Bring it down a little bit, but anyways, I figured I'd try to fly a drone live. Like you said, I don't think anyone has done it yet, so that'd be neat.
That is like a round of applause. Fantastic. Oh, so cool. So because it's closed source, like you mentioned, it's pretty important for like to be able to, I guess, modify it enough to add on your own apps to it. How exactly do you do
if
that?
they were more open source with it, well, I guess you could do it a number of ways. Like I said, there's a few open source projects that use API calls for like Python or even JS for communication back to the robot. But like I said, in this case, it's a very closed source robot, and I guess assume they're doing for restrictions dealing with the FCC. Once these things, this is like the most advanced, I think, drone that's commercially available and affordable at that price. Get the restrictions on it, so they don't want a lot of people messing with it because they're having issues with people flying in like airport areas and things like that.
Right.
But like I said, I might change the control board on this one to the more open source nozzle board. But like I said, I haven't really gotten into it too much. They're just kind of, trying to play with the idea of how I would incorporate it. I leave this thing flying around for a second, and I'm gonna I'll share my screen for you, and I'll show you what I'm doing with the other one.
Let's go on a tour. This is so cool.
Let's see if this works. All right. So let's see if it's in here. Not that one. I'll minimize this. So here's my processing sketch. It's actually just some source code I found on GitHub. I have the lead motion right on top of my laptop, and if you can kind of see, like it's checking out the points of my finger and my palm. I don't know if you can see that. Those like little dots.
Dots.
So I figure if I can get it to track like the direction, the rotation of my fingers, I can get like turn left or turn right, or if I go higher or lower, I can change the altitude of it. Like I said, what I want to do is I want to mount this wrist, so it's just like I'm using this on top of my wrist to fly this thing around, and then use like I said backup data from the GPS so I don't lose it. That's kind of where I'm at right now. Like, cause I'm just playing around with the different concepts.
Cool. How many points does the leap motion track?
I'm not sure because I've had it for about 2 weeks. I dug into it a little bit, but not too much. I know it does both hands, so I'm assuming it's like 10 points on your fingers plus your palms, so 12 possibly, probably more. But it's pretty good. Like I think I bought it at Best Buy. I should have bought it when it was a Kickstarter, but I just waited for it to get to the final product. But it's for $80. I mean, it's a pretty decent sensor. It's actually 2 cameras with an IR, kind of like how the Kinect uses it, but it's just a little bit more simplistic.
Right. Wow. So cool. Let's see.
Let's see if I can get the drone back. All right. Let's see if I can. I'm gonna take a second and I can fly back over here. See if I can recognize my house. Better. There's a little bit of a latency because, like I said, Google Hangouts and stuff.
Yeah.
Fast.
Wow. Uh-oh. Oh.
See if I can get it. So I'm kind of just like sitting in my front porch here.
It's so cool, we can hear it.
Let's see if I can see. I'm gonna be receiving.
Oh, do we see Atom? Oh, yeah, we see you.
Alright, I think that's about it.
Wow. Hey, it's Adam. Uh-oh. Oh, okay. Got it. Phew. Wow. How cool is that?
And actually, what I was planning to do, I was going to ask you, because I was playing with your Node.js from like the Oscar Hangout code set you had, and I was actually going to try to make, I was going to make like a servo controller that would command the joysticks, and then see if we could fly the thing over Google Hangout. So if you had like some buttons, we could try to fly it around like that. It might be interesting.
That would be great.
Be like.
And I ran out of the.
I think it's still operation of a drone, at least for civilians, right?
Yeah, I ran out of the free Amazon EC2, so I'll see if I can try and get some sort of server where we can.
Well, I was thinking like, couldn't we just serve it? Couldn't we just serve it on a machine and then just forward the
just
IP?
As long as it doesn't crash in the middle of trying to fly.
Yeah, I mean, I'm okay with that. I'm sure it'll be fine. It'll be running Linux, so I'm sure it'll be a lot better than Windows.
Okay, cool. So pretty soon we'll all be able to use the Google Plus Hangout extension to control the drone. Oh, very cool. This is so cool. So where did you come up with this idea to like do this? Like, what is your inspiration eventually? Is it to carry packages places using
no, I would think like it's just mostly out of I guess off the top of my head thinking what I could accomplish. Like kind of like a challenge, I guess. I mean, what I guess an application which you could use it for is for like scouting. So if you had this robot following you in like a wooded area, maybe you were looking for injured people, or you're a forest fighter, right? And you have a drone assigned to you, you could send it out and it could follow you at the same time. It's almost like that movie Oblivion in a sense. I don't know if you've ever seen that with Tom Cruise, but it could be something like that. Like an assistant drone.
This is amazing. Amazing. Thank you so much for showing this to all of us. I think we all enjoyed going outside.
Yeah, try to get outside as much as possible.
We're looking.
All right, thanks for having it, Erin. And like I said, I feel bad because everyone else here is like they built them from scratch. I built a few of mine from scratch, but just the cost of building a quadricopter from scratch almost didn't pay off for the price that I picked this up for. So.
This is fantastic. Thanks for showing it.
Thank you. Thanks, guys.
Yeah, I guess you post updates on your Google Plus account. Where can people follow this more?
Yeah, you can check me out on Google Plus. Occasionally I post there. I'm not real good about blogging, but once in a while I post something up there, so you might want to take a look. And I've got a GitHub, and like I said, if you look at my G+, most of my links are there. So.
Great. Thank you so much, Adam. This is perfect, amazing, like, it's so cool. All right, let's see, who is robot next? Dwayne. Hi, can we see Robe Otto?
Yeah. Well, first off, this is my first robot party as well.
Yay, first robot party!
I'm actually a design engineer in Rockford, Illinois, just a little bit west of Chicago. My robot is, I actually design and build large format 3D printers.
Wow.
I work with 3DP Unlimited. And when I built my first 3D printer, I was looking for something cool to print up, and I ended up coming across a site. It's called InMove, INMOOV.
Yeah.
And it's a humanoid life-size robot that you can print out on your own. It's all ran off of RC servos, a couple of Arduino Megas, interfaces with a computer. I was very interested to see Roger's presentation because that's kind of the direction I want to go forward with, something where I can get this thing to be autonomous.
Yeah.
I went out this morning and actually bought a really nice webcam, but I can't get my integrated webcam on my laptop to switch over to that. So I'm going to twist around my laptop and everything so you guys can see Rob Otto.
All right.
He's been sitting over here patiently waiting.
Hey, there's Rob Otto.
It's all 3D printed, and I chose on this build to do him with PLA rather than ABS, and that it's presented its own set of problems, but it's nothing that couldn't be overcome.
So why PLA instead of ABS?
At the time, the printer that I built at home wasn't capable of getting up to ABS temps, so I went with PLA, and I couldn't even get the color that I wanted in ABS. I went with this brass colored PLA because it happens to work out. I think it looks more human than the white ABS. So
yeah.
I crank him up here, and I have a little script that I run. I'll run for you guys, and you can see him in action. It's all open source. The entire project is open source. My programming kudos goes to Greg Perry of My Robot Lab. That's where I'm getting all the scripting. It's where I'm learning just gobs and gobs about Python scripting and OpenCV and everything that you guys are talking about here today. It's Really,
Oh,
really a
neat.
good time.
That's
All right,
cool.
he
It
just
just
livened up. I'm gonna go ahead and execute the script. He kind of moves around, so I got to step back a little bit because.
Hello, I am Rob Otto. Please allow me to tell you about myself. I currently have 25 hobby servos installed in my body to give me life. There's one servo for moving my mouth up and down, 2 for my eyes, and 2 more for my head, so I can look around and see who's there. There's 3 servos in each shoulder. Here is the first servo movement. This is the second one. Now you see the third. They give me a more human-like movement. But I have only one servo to move each elbow. That leaves me with 1 servo per wrist, and 1 servo for each finger. These servos are located in my forearms. They are hooked up by the use of tendons. So that's my story. Thank you for taking the time to stop by and meet me.
It's so polite.
That script is it's a revised version of one of the scripts that's on the site, the InMove site, and the reason I kind of toned it down a little bit and cleaned it up because I take Rob Otto to a lot of STEM schools.
Yeah.
Trying to get this technology in the hands of the younger children that they can do whatever they want to with it. It's open source is so awesome. I really can't say enough about it. I have one other script that I want to run for you guys. Rob is he's the first conceited robot that I've seen. Any of the other guys, the other InMoves that are out there, and there's quite a lot of them. They're all over the world. They're being built daily. A lot of schools are picking up on it and whatnot. And this is just a funny script that I made because I was just having fun with it.
All right.
Hello, I am Rob Otto. Please allow me to tell you about myself.
Oh.
I currently have 25 hobby servos installed in my body to give me life. There's 1 servo for moving my mouth up and down, 2 for my eyes,
He went on the wrong line.
and 2 more for my head, so I can look around and see who's there. There's 3 servos in each shoulder.
So once it starts the script, it can't stop?
I
Here
can
is the
kill
first
it.
servo movement.
I can kill it, but
This is the second one.
I'm thinking I may have to start the
Now
program
you see
over
the
again.
third.
Oh, I see.
Give me a more human-like movement. But I have only 1 servo to move each elbow. That leaves me with 1 servo per wrist,
What was the estimated cost of the build,
for each finger.
out of curiosity?
These servos are located in my forearms. They are hooked up by the use of tendons.
Dwayne, how much did it cost to build and print this InMove so far?
I actually have, I would say all total, I probably have $500 in them with all the servos. Right now I've got about 5 kilos of PLA in them. And the Megas on the back, I'll turn them around so you can see the back side. And there's a lot of cleanup work left to do back here. I've only had him. He's only been running for probably 3 months now, and I did it all over the winter, last winter.
Wow.
And it was set up to run on batteries, 6-volt batteries, and I changed that because it was a hassle with the batteries. I was always having to change them out, keep one on float, and it was just too much of a hassle. So
Yeah, batteries can be annoying. So we have one Arduino Mega there. That's pretty
two.
cool.
There's actually one
two.
Here and one over here. This one on this side just controls the right arm and shoulder. This one on this side controls the left arm, his head, the eyes, the jaw, and his neck. And it's all he actually has cameras in his eyes where I can run it through OpenCV, and he'll track. You can get him to track humans and whatnot. So like when I take him to shows or maker fairs, I can have him lock on to a person walking by or a person that he's interacting with, and it just makes for a little better user experience to me. The Connect that's in the center of his chest is there for point cloud and ultrasonic ability, to where he can sense if someone's moving up on him or where he's at in reality if he's interacting with somebody.
Wow.
It's a very cool project, and there's a lot of people behind this.
Yeah.
With my robot lab, it's 24/7. People on there from all over. I thought one time I had actually seen Roger on there. And the community that's involved, that's behind it, everybody is very friendly, eager to help. You know, if you're new to programming or new to 3D printing, they're right there to jump in and get you through any sticking points that you have or anything. It's a very, very cool project. I really enjoy it.
Fantastic. So, can it run the script now?
Yeah, let me.
Man, $500 should have cost like $5 million a few years ago.
And that's the thing, you know. There are much greater robots out there. Asimo is one in particular that I always see a lot about. But you also have to understand that Asimo has $300 million behind it. So I definitely do not have $300 million to put into this. So it was a monetarily friendly project, and it keeps developing. Right now, they're down to the lower torso. He actually has a stomach now and hips where he can flex, go forwards and backwards, twist at the waist, and right after that, as soon as that gets released and everybody starts printing that, they're going on down through the legs. The dream is to have him walk one day, and I really think that's going to happen, especially with the motion sensors and for the droids that everybody's flying around now. That motion capability is huge for robots that are going to walk around. Let me see if I can get this script running right now. I'm gonna Sorry, I got to key something real quick. He doesn't want to behave.
No. Bad Rob Otto.
Yeah.
Alright, well, thanks for trying anyway. It was so cool to see it work before. That's very cool.
I actually have another one sitting over here on the...
You have another in-move robot?
No,
so they're both friends?
It's the actual... it's they call it the finger starter kit.
Oh yeah.
And it's been sitting over here on my 3D printer running the whole time during the show.
Aha, yeah, that's what we heard.
All it is this is the starter kit that you can see if this project's for you. You go to InMove site and you can download it, print it out, and put a cheap 996R servo on it, and it takes a Uno board and power supply. That's it. And you can actually run this one. You don't need the power supply. You can run it directly from a laptop or a home computer, desktop computer, and a little bit of fishing line and hours of fun.
That's great. Yeah, great way for a starting kit before starting on the big adventure, that's for sure.
And that's what it was about for me too. But I started with that, and once I got that and it started moving, that's it. I was hooked.
Of course.
My printer at home was running pretty much 24/7 because I monitor my printer through a web-based IP cam. So I was at work and checking on it all the time to make sure that it was still printing, wasn't running out of filament or anything.
Yeah. Next time you'll have to show us your printers and of course Roboto, the progress on it.
Absolutely. It's I call it the Fisnadestein because it's a bored together mess of things that I was throwing out. I had an old glue.
All right.
It's not a glue robot. And I hacked it up and put linear stages in it, reprogrammed it, and
cool. Thanks for showing us the Roboto and explaining it all, and very cool. Thank you so much for joining in.
No, thank you so much for having me. I really enjoy it. You'll definitely see me again.
Great. We look forward to it, definitely. All right, so last but not least is Robot Goldfish, who has a new Robot Goldfish.
Yeah, I'm feeling just a tad bit outclassed by some of these projects. Can you hear me?
Yep, we can hear you.
Okay. One thing is I printed some wheels for the old Robot Goldfish because the previous ones broke. But this is RG2. He has one continuous rotation servo, and the wheels have one-way clutches in them so that they'll only roll forward. And the way he works is by going back and forth. One wheel moves forward, one stands still. And if I wanted him to turn around, he would just pivot on one of the wheels. And I've been thinking about this for a long time, but you know, and that's pretty much what I got so far. I haven't been doing much.
That's quite a clever use of the continuous rotation servo and the clutches. It makes it look like it's actually swimming on the desk, sort of.
Yeah, I had the idea for the method of movement, and I had the container, and I probably had this container for a year until I realized that the two would be perfect together. It uses a AT-Tiny 85 for the
cool.
brain. I'm kind of going the opposite direction of most people and trying to do really simple, because it has 8K of RAM, so you can do a lot with this. I think a lot of the things we put Arduinos in don't need anywhere near that kind of power. But that's what I'm playing with.
And so what can it sense right now?
Right now it can't sense anything, but it's going to have, this is a infrared sensor, so it has the ability to read. It's going to follow a black line, and by moving back and forth, it's also sweeping the sensor across the path. So what I want it to do is eventually read several times as it goes across the line, use that to calculate how far to go back the other way, and keep the line centered in the sweep.
Cool. This would be a really fun robot for kids to get started with it.
Yeah, I was thinking this might be a better idea than some for the starter robots for school, because the chip is cheap. If you could have one Arduino that you use to program them. It would also let them have an Arduino to do slightly more advanced projects. And if you can squeeze everything you can get out of one of these chips, you'd be really set up for getting a lot more out of the bigger boards.
Sweet. Thanks for showing the new and improved robot goldfish with sunglasses too. Yes, that's so cool.
Well, it's got a case anyway, but I'm gonna have to get that finger kit, because I could mount that on the car. That'd be cool.
It could be like a tongue. It's trying to eat plankton. What do you think robot goldfish eat? Like algae, robot algae.
Robot worms.
Robot worms. Yeah. Cool. Thanks for showing this to us.
Oh, my pleasure. It's like it's a different idea. There was some talk about one motor robots, and at least this shows that one motor robot can turn and move forward.
Yeah.
Can't back up, but what do you want for one motor?
All right. So I think we got everyone, right? Or I just, yeah.
Oh yeah, and thanks for having a party again. I'd missed them, and it's nice to get together with everybody.
Oh, fantastic! I'm glad everyone's so enthused about it. I was looking forward to it too. It's a lot of fun. All right. So I hope that maybe people don't mind if I talk about my robots as well. Because I don't want to be like, oh, look at my robots and I'm the host. That would be weird. But, okay, anyway. So, I'm working on this idea called an automatic food slicer, and that's this robot partially right here. So, what the big idea is for it is it will be able to slice food using an end effector, sort of like this. But it will also have another axis to move back and forth, and then also back and forth this way. Right now it only moves up and down. So let me show you the work that's been done on it so far. Okay. So here you can see it moving up and down. And this is just a little toothpick test that I designed. So this end effector sort of can come apart really easily. it's designed like this so that when you have to take it out and clean it, it'll be easy to do with one hand. And so there is enough power in the gear set and the motor to actually poke this little piece of sticky tack that I have. So with some additional modifications, it should be able to slice food, hopefully. The way that I have it sensing right now is it's using a DIY encoder. So I created this little encoder wheel. It's 3D printed with black paint on it, and there's a white LED shining on it and a light sensor detecting the light back. And there's also buttons on the top of the gear set and on the bottom so that it can detect when it hits either the top or the bottom. The reason why I went with something silly like this is because it was all that I had at the time. But one of my friends is sending me better encoders, so I look forward to improving that a bit. And then I was sort of experimenting with, like, how do I want people to be able to slice food? Like, they could just press a few buttons on, like, a remote control or whatever, but it would be really cool if they could just use one finger, like, across a tablet to basically swipe the food and cut it. So I've been using augmented reality to track a marker like this one, and on the screen you can see, like, wherever this is. So the position of this, and I'm thinking maybe I'll have another one, and then it will be able to figure out wherever you swipe, then that's where the robot will move to, and then cut the food. But then, as sort of like a moonshot idea, I was always wondering, like, you know, when you sort of have food and then, like, if you're eating it really slow, you have to reheat it in a microwave. Well, what if this was the microwave and there would be a heating element on another end effector that could heat each slice of food? So it's sort of changed from this idea of an accessibility robot to, like, a microwave or food warmer slicer of the future. And I'm totally out of my waters on this project because I have no idea what I'm doing. And it took a long time just to get this part set up. So it's been an interesting summer so far. Yeah. And the robot next to it is my classic robot, RoboBird, which has a new 3D printed chassis on it. And I think it got unplugged there. All right. So here's an example of the holes that are being poked in it. So yeah, that's my robots. It would be a little tricky to demonstrate the AR app, but hopefully I'll figure out a way to show that and create a video of it. Not really sure how that's gonna be able to be recorded just yet. Yeah, okay. Thanks for listening to my robot presentation. And so with that, I think it wraps up this robot party for this lovely day. It has been so cool to see all of the robots. We saw, like, so many pages of notes here. We saw a kitty robot, saw a robot with a spoon to feed you food, another humanoid robot called Jin, saw a medical robot, so if any of the robots attack you, then you'll at least be able to get medicine delivered to you by a robot. We saw an autonomous navigation robot, which was just so impressive with all these features on it, and streaming video. And then we saw an idea where another augmented reality idea where you can move your head, for example, and the robot will reflect that. Then we flew outside with an autonomous, or not autonomous, with a flying robot, UAV robot, and got some ideas about how to control this in the future using your fingers, and also another augmented reality application idea. Then we saw another humanoid robot, an in-move robot, which is so cool. Then we saw robot goldfish, so even fish in the future will be robots with sunglasses. And we can also have our food cut by a robot too. So this was absolutely fantastic. Thank you so much, Andrey, Ashim, Atom, Dwayne, Louie, Robot Goldfish, Roger, Roger version 2, Stephen, and all of the viewers out there. Thanks for watching. So this will be recorded live to YouTube, and I'll probably make a demo reel out of this video as well. It was just amazing. Thank you so much, everyone, for showing your robots. And stay tuned to the Robot Party group for the next date and time of the hangout. We'll figure out a fun one for everyone. All right. Thanks again, and see you next time. Bye.